let's keep going. So, I don't know if that's going to be very accurate. You're going to be able to quite see what I'm doing on this video, but we'll see. Alright, 120. Without drawing it, which quadrant should it be in? 1, 2, or 3, 4? Should be in quadrant 2, because I know that this is 90 and this is 180, so it has to be in between. It's probably a little bit closer to 90 than it is 180, so I can put it there. Here's my initial arm, there's my terminal arm. This is my angle at 120 degrees. The second one is not 120. It is 180. Okay? Think about skateboarding. So if you go 90, basically you're breaking up into increments of 90 degrees. Okay? If I'm standing here, I make a quarter turn, I'm at 90 degrees. If I completely, what's that saying? If you go 180 degrees, you start facing this way and you spin the whole other way. If you do a 3/4 turn, you're at 270, and you do a full turn, you're at 360. Okay, that's snowboarding, skateboarding. That's how they rotate those pieces. I know, right? That. Okay. Last one, without drawing it. Quadrant 1, 2, 3, or 4. Quadrant 4. So it's between 270 and 360. What's it closer to? Probably 270. So I can put it a little bit here, there. Now, here's the big thing. Where am I showing that this angle is being measured? Is it being measured from here to here, or is it the long way around? Okay, this is 390 degrees. Make sure that you understand that we are always opening. If I start at my initial arm at the positive x-axis, I'm opening counterclockwise. Clockwise works this way. We are working counterclockwise. Make sense? Are we all good with that? Any questions so far? Good? We're going to do something about it. Complete a Mexican. I don't know what a Mexican wave is. We're not going to do that. We're not going to do a Mexican wave. I don't even know what a Mexican wave is.
You should look it up for us.
Just Google it.
Who said it? Me. Taylor.
8 quarter recess.
So actually, we're going to go maximum.
17-minute mega.
The Max Arena.
What?
Okay, stand up. Stand up. The Max. Yes, Kate, you guys stand up. Can you wiggle? Sorry, I didn't know I was going to do the Macarena.
Well, what did you think it was?
I thought maybe not the Macarena. Why is nobody else doing that? Come on! Is he doing this for 3 minutes? He's up. He's still doing it. Alright. Oh, we could have done the wishy-washy.
Next time.
I'll find out what a Mexican wave is next time. Alright, what are the components of a coordinate grid? We actually just talked about that. Good, I wanted to bring that up, but we already said it. Components of a coordinate grid, we just said. Review. 0. What's this one? 90. What's this one? 180. What's this one? And I don't know if we actually said this, but just to be deliberate, what does this one also have to be? 360. Good. Okay, we've got our 4 quadrants. The next piece that we're going to talk about is reference angles. Yes, Jared? You found it? Can you share it?
It's just like.
You need to get up and show us now.
You do the wave. It's called the Mexican wave because it was invented at the 1980 World Cup in Mexico.
So the actual wave you see in sport is actually a Mexican wave. Now I know something. This is
Wait,
great.
why is it 0?
Why 0? We have to start somewhere, right? So if it's either you know, look at it this way, Madison. I'm looking at you right now. This is where I start. If I spin, I've now done one full spin. It doesn't look like I've gone anywhere, but I've actually done one full spin. Kind of is real. But that's why it's either 0 or 360. Make sense? We're going to talk about reference angles right now. And they're based on your understanding of quadrant 1 from 0 to 90, alright? Reference angles break down each term that you have different angles that represent the same distance from the x-axis. Okay? So if I use the example of 60 degrees, I know this is very small, so I'm going to give you a little bit of a blown up version. We'll use another example shortly. If I'm using 60 degrees in quadrant 1, I am literally how far away from the initial or the x-axis? I'm 60 degrees away. If I want to show the reference angle of 60 degrees in quadrant 2, I'm actually at 120 degrees, but I'm 60 away from this axis to the terminal arm. Okay? We're going to show you a couple formulas to really represent this, but I want to just give you this understanding. The third one, the third reference angle, again, here's my x-axis. It is 60 degrees away, but it's also, what's the total angle? 240, because it's 180 plus the reference angle. And the last one, okay, it should be, this is not a good example, because that's at reference angle 45. So my reference angle, if I'm in quadrant 4, should be, if this is my coordinate grid, this is my x-axis, how far away should I be from this point? This should also be 60. What should my total degree be? 360 minus 60, which is 300 degrees. I don't know why that's there. It's just giving you another reference angle. They're saying that the reference angle is 45. So let's do another example. Let's say I give you a reference angle. And actually, let's not use this. We'll use I'll go real with you and give you a nice coordinate grid so it actually makes sense. Let's say I give you a reference angle of 30 degrees. Okay? Where is the 30-degree reference angle in quadrant 3? Who thinks they could give me a crack at where that reference angle, or how would I construct that reference angle for quadrant 3? Not quadrant 2, quadrant 3. Kara? You're not sure? Oh, you're like, was that I don't know what's going on? Okay. For quadrant 2, how far, if this is my x-axis, how far up should my angle be? Should be 30 from the top. So, if I make this 30, okay, this shows up as 30 degrees away, correct? What's my distance from the initial to this angle? How do you think I could figure that out? Well, I know that from here to here is what degree? 90. Okay, here to here is 180, so that's another 90. If I'm 30 away, 30 from 90, how much do I have left for that second quadrant? 90 to 180 is a difference of how much? 90. 90 minus 30 is 60. What is 60 plus 90? I could do 180 minus 32, which makes good. 150. Would you like another formula that kind of gives you that? You kind of just did it. Yes, Curtis? The first 30? This is my reference angle. So what a reference angle is basically it's the angle in quadrant 1. Okay, if I tell you you have a reference angle and I say it's in quadrant 1, that is you need to find comparable angles at the other 3 quadrants. Okay, so I just gave you an example. I just said, hey, this reference angle is at 30. Where is this other quadrant? Is 30 degrees as a reference angle for the rest of them? Okay, are we good with reference angles so far? Ish. We'll do another example. So the idea here, kind of Jared, the logic that you use, there's actually a formula to find the reference angle for quadrant 2. If you are looking for 150 degrees and finding out what that angle is, after you figured out that I know I'm 30 degrees away from the x-axis, how I find the reference angle is I take, for quadrant 2, 180 minus the reference angle. I'm just going to call it R for reference angle. 180 minus 30 is 150. That make sense?
So could you do 90 plus the reference?
No. 90 plus the reference would give you 120. What's the problem with 120?
It's not.
Okay, that would be like saying that it was 30 degrees here from this point here. Remember, the reference angle is always the angle from the x-axis up. That would be from the y-axis. We're always dealing with the x-axis, okay? So now to answer the question, where does, for quadrant 3, where does this line go? Does it go 30 degrees from the y-axis or 30 degrees from the x-axis? Does it go up or down? Down or up?
Well, it has to go down.
Well, I already did up, so I have to go down. So this is now 30 degrees away. Okay, what is my total reference angle? Oh, let me keep going. 180 plus 30, which makes this has to be 210. The formula you would use, 180 plus the reference angle. And the last one. Where does the reference angle go? 30 degrees from the x-axis or 30 degrees from the y-axis? 30 degrees from the x-axis. That makes this 30. And if I were to do this again, without making too much of a mess, what is that total angle? If this is 360, what do you think it's going to be? 5 hands. 5 hands tell me they know what this angle must be. If it has a reference angle of 30. 1, 2, 3, 4, 5, 6. Taylor Cricket. What is it? Ask your boy Andrew. 330. And how I could find that out using a formula is 360 minus the reference angle. Okay. And obviously if I have quadrant 1, in case you were wondering, it is literally just the reference angle or 0 plus the reference angle. Okay? It really looks bad, but does it make sense? Yes or no? We're good? Can we move on? So, if I were to give you a reference angle of 25, actually you're going to do the same thing. I've got 4, you pick one that I do, you guys do the rest. Which one do you want me to do? First, second, third, or fourth? The third one, 8 degrees is my reference angle, and I want to show where it's at in quadrant 3. What I like to do, when I'm given this question, I'm going to draw the reference angle. The reference angle is at 8 degrees, so it is right here. That's quadrant 1. Where is quadrant 3? Top or bottom?
Bottom.
Bottom, left or right? Left. If I know that my reference angle is 8 degrees up from the x-axis, this has to be 8 degrees down. So this here has to be 8 degrees. The total angle starts from my initial arm and goes to this reference angle. What's the formula that I know? If I'm in quadrant 3, it's 180 plus the reference angle, so it's 180 plus 8, which is 188. That's all I'm doing. Find that reference angle, sketch where it's at, and then you can apply a formula or apply logic. Okay, Jared, you used a very good example of, well, I know it's at 180, so I just subtract or add depending on what quadrant I'm using. I want you guys and girls to try the other 3. Go.